Metasump. And here it is. Okay. Is my screen visible? Can somebody confirm? Do you see the presentation?
Yeah, we can see.
Okay, great, thanks. So this module is on operations management. So it covers production, but also warehousing, procurement of machines, installing machines, labor, and so on and so forth. So the content of this module will be some introduction and definitions. Then we'll be looking at process design, production layout planning, forecasting, capacity planning, then organizational planning, both from raw materials perspective and labor, so employees, aggregate planning, the inventory, and then some modern aspects of operations management being lean manufacturing, Six Sigma, and then of course production needs to come up with good quality products, so a little bit on quality assurance and quality control. But first, let's look at this movie. I'll hope this now will work. I apologize, I have to stop sharing my screen because I have to, when I start sharing, indicate that I want to have the sound also included. Go down. I have to like this. Where is now my presentation gone? Here it is. Okay, and now hopefully this will work. And it doesn't. It's a pity. I tried this earlier.
Every year, 2 billion people take to the skies. That's more than the combined...
This is an introductory movie, but I have to close my sound, apparently. Did you hear the sound of the movie?
Yes, Professor.
Okay.
Every year, 2 billion people take to the skies. That's more than the combined population of China, the USA, and Russia. And they all have one thing in common. They're hungry, and they need feeding. So, how do they do it? 5 a.m., Dubai Airport. The overnight from London Heathrow has just finished unloading its passengers. In less than an hour, this plane has to be clean, fully stocked, and ready to fly. It's time to go to work. This is the A380 Super Jumbo, the largest airliner in the world today. It can carry 644 passengers. But this big bird causes some big problems for the ground crew. The catering door is over 8 meters up, so custom-built high-loader trucks have been designed with hydraulic pumps hidden in the chassis, capable of lifting the entire rear section the height of an airliner in just 12 seconds. Before they can start stocking up for the next flight, there's a mountain of washing up and waste to deal with. Enough to fill 2 of the 20-ton high-loader trucks. Within minutes, the truck's payload of aluminium catering carts is being unloaded at the largest airline kitchen in the world. The 21,000 square meter Emirates Flight Catering Facility. over 150 flights unload 5,500 carts here every day. That means over 30 million trays full of washing up rolling through these doors every year. This kitchen is cleaning up the leftovers of a small city every 24 hours. First, the fully laden carts are stowed in stainless steel racks to begin their journey on an electrically powered monorail system. Half railway, half high-tech fairground ride, the monorail stretches for 2.55 kilometers across 3 floors, the largest of which is the size of 50 basketball courts. This vast, sophisticated network has to operate like clockwork to get the thousands of carts emptied, clean, and ready in just 25 minutes. Every movement of every hangar is tracked and controlled from a central computerized monitoring room. From this nerve center, the carts can be directed, just like trains on a railroad, to different destinations for storage, repair, or reuse. All at the press of a button. First stop is the warewash area. To handle this industrial scale mess, this part of the kitchen has to be more factory than restaurant. A line of workers empty all the carts by hand, packing the rubbish-filled trays one by one onto 160 meters of conveyor belts, which drag them away to their fates. This tsunami of washing up rolls into 3 17-meter-long industrial washing machines dirty and leaves sparkling clean just 6 minutes later. Between them, these machines can handle 1.5 million items every day. That's 15,000 loads for a full-size domestic dishwasher. On the other side, the belts roll on to the colossal storage facility, where the airline keeps enough dishes to serve the entire population of Las Vegas for lunch and dinner. Pottery in motion. While the dishes are done, the monorail brings the empty carts up 2 levels to the kitchens and food assembly area. At 6 a.m, a hot, spicy curry might be hard to take, but in a facility that caters to flights across every time zone, breakfast, lunch and dinner are all served round the clock. With more than 100 flights leaving every day, this building alone has to produce over 20 million meals every year, so there's no time to stop. Everything is hand-prepared by qualified chefs. It's restaurant food cooked on an industrial scale. This kitchen gets through 2.2 million eggs and 50 tons of lobster meat per year. Menus are planned according to the destination of each flight. From curries for Karachi to satay for Singapore, every meal is crafted by a team of chefs drawn from 47 nations and trained in the cuisine of 26 different countries. Everything that comes out of the kitchens is cooked, then taken by rolling conveyors through blast chillers. They flood the dishes with super chilled air, which absorbs the heat left in the food, preventing bacterial growth. From the belts, the food moves onto a massive battery of 47 giant fridges, where it's kept at a safe temperature of 3 degrees Celsius until it's ready to be assembled. Of course, a meal isn't proper airline food until it's on a plastic tray with a bread roll, cheese and crackers. The 3rd floor of this vast building is where the magic happens. In an assembly area the size of 2 football pitches, 145 women work in lines putting the meals together. If these ladies so much as stop for a moment, some unlucky passenger is going to miss out on butter or jam. It can take 30 of these carts packed with food to feed the passengers on an A380 for just 1 meal. An hour after landing, flight EK201 is being loaded, ready for takeoff to New York. These super long-range aircraft can fly for up to 18 hours without refueling. That means a load of 122 carts for a single flight. With more than 150 flights a day, getting through 30 million meals a year, this record-breaking facility is going to have to keep on cooking.
Well, this is of course an example of a very large enterprise, and then probably they were talking about business class, because lobster I have not yet experienced being served in economy. It's mainly the choice between the chicken or the pasta on plastic plates. Of course, in business it's a different story. But the same principles, of course, apply to smaller organizations, smaller enterprises, and smaller operations. And we will be discussing some examples later on.
Of course, a meal.
Okay. So, definition of operation management. Operation management is management concerned with the process of production, but also related to inventory management, labor management. And it can be both or on products, but it can of course also be on processes. So it's ensuring that business operations are efficient, sustainable, and also safe. In the past, during the industrial revolutions, you had a lot of accidents, and people were not really taken care of, or labor people was not taken very well care of. So now this is, of course, also from a legislative perspective, very important. It's also the drive for being efficient, so as few resources and as little waste as possible. And of course, it needs to be good quality products, so meeting the customer requirements. So if people ask what is actually quality of a product, it's that what your customers are expecting. So it's managing the process that converts inputs into outputs. So inputs being materials, labor, and also energy, and outputs being goods or services. So operation management is a field concerned with managing and directing all technical, of course not R&D, or technical functions of a firm or an organization. It includes, well, it's part also, of course, also from executive management. It's looking at manufacturing, production systems, how the factory is being designed and managed, equipment procurement and maintenance, control of the process of production, managing the people working in the factory, and analyzing the systems, productivity analysis, cost control, planning of the materials, planning ahead so that you always have sufficient materials at hand to work. And then new aspects or more modern experts is QC management, so quality, safety, health, and environment, all embedded in one manager. And then it's very important to be as energy neutral and as mostly sustainable as possible. Here you see a schematic of this process of operations management. So it's inputs going over the conversion process, which is one of the core competences of a company, and then resulting in outputs. So it's planning as well as organizing. So planning on design, on procurement, on what products need to be produced by when. Organizing so that you have sufficient materials and people at the workstations, and then controlling how things are done, and of course controlling if your goods or services are produced according to specifications. So it's input, converting process into outputs being products or services. It can be a wide range and then some in betweens between product on one hand. So a typical product is salt. You see here some of my children when they were younger, and we were at a huge dried lake in Tunisia near Tataouine, where actually they filmed Star Wars, the first Star Wars movie. And this is just a huge plain of salt, And here just trucks come in, they scoop the salt, load them into trucks or in containers, and then it's shipped around the world as de-icing product. So this is very much a product dominant operation. And then the other spectrum, you have, for instance, teaching, like Ghent University, where it's just a service. So it's a service dominant entity. So I hope you're all satisfied with your service provider regarding the teaching. And then you have in-betweens, and an example is, for instance, a fast food shop like a McDonald's, where products are being produced and also customers are being served. So a little bit of history. So before the Industrial Revolution, we're talking about 19th century approximately, we had domestic systems mainly and also crafted guilds. Then in the 18th century, with the English textile, the Industrial Revolution started. Another big step was in the early 20th century with Henry Ford, who mentioned, I want to have a car for every American. So he started up this assembly line process. You see Henry Ford here. And then you had a good friend of him, was Frederick Taylor, who started then also operations management as a scientific or as a discipline to be studied. You see Taylor here. It was very harsh, so it was just focusing on efficiency, and the workers were not very well taken care of. As I mentioned earlier, there were a lot of accidents. And then a next step was mid 20th century with the Toyota Motor Company, where they introduced some of the new operation management systems and concepts like just in time. And then towards the end of the 20th century, so in 1987, ISO systems were introduced, so International Organization on Standardization. So here you had then standardized operating procedures for instance, the operations. And then you had more recent trends in operation management, and then we're talking about lean manufacturing, the Six Sigma, which actually came from Motorola and some other companies. So operations is thinking in processes. We already discussed that. So inputs could be labor, raw materials, also financial resources, energy, know-how, and then the process. So in many companies, the process of converting inputs to outputs is a core competence. Here you can have a clear view on what basically the company is all about. And then the outputs need to be the desired products as much as possible, with as little as waste of waste as production as. So the fewer the better regarding waste. And then you have, of course, the context, so that's society. So you have quite strict environmental legislations. You have legislation on workers. You have legislation on waste disposal, on products that you are allowed to use, and so on and so forth. Now, why is operation management important? In a traditional way, or in the past, profit was basically cost plus a amount of profit, and that was your selling price. So you had just at your cost, you added the profit you want to make, and that was a selling price. And then, of course, if you increased the profit, you increased also the selling price. Nowadays, it's different. Everybody can easily go, for instance, on the internet and compare prices. So you have, for similar products, more or less from the public, a same selling price. And then the selling price minus your costs, so this part gives you the profit. So now, in modern times, you try to reduce the cost as possible, since your selling price is the same. So if you can reduce the cost of production, your cost of goods sold actually, then basically you have more profit. So in the past, it was just whatever cost, you add up a profit, and that was your selling price. Now, selling prices are for similar products are quite fixed in the market, and if you have a lower production cost, then you have a better profit. You have operational management strategy, so this is thinking ahead. This is taking into account a bigger picture, which is also determining your day-to-day practice, which is then more tactical operational planning. You have different production systems. It comprises technology elements, including the machines, equipment, and then, of course, the workers, so labor, and then information and the skills of these workers. And of course, whether you have goods produced, so tangible articles, or you're in a service sector, it doesn't make a difference. So all principles still apply. You have different classifications of production systems. First is a process production, where you have starting materials are transformed into a final product. So for instance, you have chemical reactors in the pharmaceutical industry, where you can have different reactants or ingredients resulting after a reaction process, which you have different types, into a synthetic new product. Versus part production, that's manufacturing, for instance, and assembling on a line, and this can be, for instance, cars or an HPLC. Another view of looking at the classification is based on lead time. So manufacturing lead time versus delivery lead time, and this has to do also with the customer order decoupling points. So you have classification of ETO, so engineer to order, over to purchase to order, make to order, and make to stock. For instance, make to stock is cell phones. So the factory is not going to wait until a customer places an order to start producing a cell phone. So here you're producing cell phones which are in the warehouse, which are going to companies around, shops around the world, and then a customer goes and buys a cell phone. But it's make to stock. On the other hand, for instance, if you want to have let's say an engineer to order, if you're going to buy a house, you go to an architect. So most of the time, the architects or the construction guys are not building a house and then looking for a customer. If you want to have a new house, most of the time there is a person coming to ask to design the house, and then you start the construction. So that's from going from engineer to order all the way to make to stock, and vice versa. For process design, there are 5 generic types: a project, so that's one of a kind, so custom tailored on the request of a specific customer. A job shop, that's the next step, so that's manufacturing of small batches of many different products, where you have different workstations that can do a variety of tasks to make these different products. For instance, here you see in which I visited a candy shop in Tunisia, where they had different workstations, but it was handmade pralines and handmade chocolates, very tasty. But it's moving already towards almost with people who were very creative in making things, but it was getting standardized. So it was going already from a job shop with a lot of people to a batch system. So that's a step above a job shop, and there's more standardization and repeated handling and repeat products. And then you have an assembly line, which is a next step. So that's for the production of a narrow range of standardized products. So you can't do many different products. So you have a series of well-defined products, and the line or production system is in such a way that it's all towards the production in an efficient way as possible of a well-specific product. And then you have a continuous flow. That's highly standardized, very few products in an endless system. So you have a continuous input coming in, and you, on the other hand, you have the same product always coming out, in a continuous system. If you look at the manufacturing, the cost, so job shop is more expensive, project is even, of course, much more expensive. Then you go to batch, then you go to assembly line, then continuous flow. An example of, for instance, a project is a house or a boat or an airplane. Then, job shop and batch we saw here. Batch is also the pharmaceutical industry. Assembly line, a typical example are cars. And continuous flow, a nice example is a petroleum cracker, where you have crude oil coming in on one hand, and then you have the distillation, fractionated distillation, and you have petrol, diesel, kerosene coming out on the other hand. So you're just feeding it barrels of crude oil, and on the other hand, you have a tap turned open to get your petrol and other derivatives. The process design. So once you have your ideas and your technology developed and you want to start a process, you can have a schematic overview of in great detail of your process. And some of the elements used here are, for instance, this square as a process, in which you then describe the process, a decision, this diamond shape, parallelogram on data input, terminator. Here you see more examples. Start and the beginning of a process. This decision, inventory out, finished goods in, and so on and so forth. You can of course do it more in a cartoon way, like the brewery process here, where you have malt going in through the different steps and finally beer coming out, being distributed, which with a little bit description here, but of course it's not using these characteristic flow shapes as we discussed in the previous slide. But then this is quite helpful because it also links it to different equipment and equipment which you can then procure to actually build your factory and production line to produce the products or also the services. You see a service flow here. This is actually a taxi company. I'm not sure whether it will exist still a long time with Uber coming up, already available in many countries. And here you see a process flow of how this service company, being a taxi company, operates. Here's an example of a smaller company, my distillery. So this is a process flow on how to produce one of our products, being a gin. And so here you see the different process steps, data coming out, products coming out, information coming in. My apologies that this one is in Dutch, but it's just to give you an example of the different steps. Important in this process is the capacity that you have, how long it takes, what materials to be used, how much labor and which expertise and skills need to be at which place, and then energy, being gas or electricity consumed. How you design your operations is also directed a little bit whether you have a high contact system with your customers or a low contact system with your customers. You can go and read through this, but very important, for instance, if you're an architect and you want to deliver a service to customers for construction of new houses, buildings, factories, it's important that you, as an architect, your office is nearby your customers. On the other hand, if you are a company producing cell phones, you don't need to be producing these cell phones nearby all your customers. So you can do it in a different way. You can locate your factory where you have a lot of good tax conditions, where there is good talented labor available, and so all different things that can be taken in account, except the fact that you have to be very, very close to your customer. Then we move to layout planning. That is actually determining and designing the flow of materials and where your equipment is being located and how labor can be allocated in such an arrangement that it's efficient and it doesn't waste too much time. And yeah. So this is also linked to what we will be discussing in later slides, lean manufacturing. There are two basic types. So you have intermittent operations, so stepped operations, so low product volume. You have interrupted production flow. There are a lot of changes required, and you have a larger range of products you want to make. And then, as we discussed already, continuous operations, so high product volume with a very few different types of products you want to produce, for instance, a car on an assembly line, or the petrol in a petroleum cracker. Then regarding design for a layout, you have process-oriented. So you have different goods coming in, you have different equipment to do certain processes. Product oriented, so it's focusing mainly on the production in an efficient way, as quick as possible, of a specific product. That's product oriented. And then you have fixed position oriented. So you have, that's a very different type of approach. So you have one specific final product which stays at the same location, and then different teams are pulled in to work on that product. And an example is, for instance, aeroplanes. You can't have an assembly line of aeroplanes, or not at least these big ones. Or, for instance, boats, so large vessels. There as well on a shipyard, the product stands still, and then different teams come in to do the work until the boat is released from the shipyard. Layout planning, how to do this. You have graphic and schematic analysis. You can do this, for instance, if later on, or perhaps some of you have done already, make cutouts of equipment, like when you want to build a kitchen, or for instance, if you have a room in a dormitory and you want to see how to install as efficient as possible a desk to study, and a bed and a cupboard, so you can have the building on scale, and then you cut out the different items also in scale, and you can start shuffling it around to see what is the most efficient setup. You have also, of course, software programs to do that. It can also be presented in a diagram, so for larger setups, where you have then the different workstations, and then the flow of the process and the different tasks done at the workstations. You can do then some calculations using mathematics, and one of these formulas is the load distance model, where you look at the number of loads moving between two different stations, how many times, and also the distance between the different stations. So in order to have an optimal design, so that you have the least distance to cross as few times as possible. So for layout planning, identify all the different activities in your process, identify the required equipment regarding capacity, size, Also determine the sizes needed of the equipment and related to that, the energy consumption, water consumption. This is important for some countries, like in Belgium, for your environmental permit. This determines where which class of environmental permit you need and you can acquire. So there are very strict regulations to that, and for that often they request information on the size of your equipment and the amount of energy being used and water being used and so on and so forth. Determine the required space. Don't forget the height. Like, okay, this is typical, again, university. So the campus of the bioengineers are going to move to another location. And then you had a whole committee looking at buildings. But then I was asked to sit in one of the discussions, and I mentioned, so they were taking into account and doing all the measurements on square, the amount of square meters. But I said, yeah, but for some rooms and some locations, like a pilot room, you don't have to think only about the surface, but also the height, because some of the machines are higher than just a normal ceiling. So anyway, so they had to adjust a few things. So then determine the best flow and design, as we discussed in the previous slide. Also determine the required infrastructure and finishing, for instance, of federal agency on, for instance, food safety or on pharmaceutical guidelines. So, for instance, there needs to be a washable floor with tilings. The ceiling needs to be able to be washed. Air current is there are specific regulations and specifications for that. Fire protection. So the fire department has specific guidelines on what needs to be in, how many fire extinguishers need to be present for at which location. So they're all things that have to be taken in account when you do your layout planning. For the layout planning, take in account energy, the safety, efficiency, capacity, flexibility. So if you're very rigid structure and things need to be changed, you have a problem. Automatization, we discussed also during creativity innovation, the importance of automatization. The effluents and many other things, waste disposal. And here you see, for instance, from the beginning of previous century, a yeast factory done in a very efficient way. Sorry again for all the different steps in Dutch, but the idea was to use gravity for continuous flow. So they started all the way up, and then by gravity, the different intermediate products were moving down, flowing from one level to the other for a next step, for a next activity. And finally, they ended up at the bottom where the goods could be loaded, the yeast could be loaded and moved to the customers. And then, of course, if you start here, or you have to bring up solid materials with a lift, or liquid materials which can be pumped. So, but this is how gravity was used, without needed to and that's a very efficient way of looking at energy. So it's just gravimetric instead of moving and pumping and carrying intermediates around. This is an example or a template I made which can help you for layout planning. So you on one column you determine, you write down the activity required and the personnel, the equipment which is needed, how much space is required for this equipment, and also for tall equipment keep in mind the height, and then the required energy, for instance electricity consumption, gas consumption, and the required for instance water and cooling water that is required. And this gives you then the total of square meters, total energy requirements important for your environmental permit. And then you can also decide to build or to buy a location. For instance, in Belgium, you see here prices for buying building. So it's about 100 euros per square meter for industrial land, 200 square meters for construction with a low degree of finishing, up to 1,600 euros per square meter for a high degree of finishing, like for instance labs and offices. For renting, for East Flanders, the region, and of course renting prices differ, and this also differs throughout the year, so it's only increasing. So in Belgium for renting, you see prices here, so 36 to 150 euros per square meter per year for offices and warehousing. And this price difference is mainly depending on where the location is. If you're far out in the middle of nowhere, you're going to pay less than, for instance, let's assume being in the city of Ghent. For layout planning, as I mentioned, you also have computer models, software available, which can help you out. And whether you do these cutouts or with computer models or mathematical approaches, a layout design is good if it meets the desired output capacity, the sequence is technical feasible, and it's an efficient line, and you're allowed to do it at location that you want to do it. I mentioned just in the previous slide inside the city of Ghent, but inside the city of Ghent you can have, for instance, some artisanal activities like a bakery shop, but we can't put a petroleum cracker, for instance, in the middle of a city because it's not allowed. Here you see a layout planning of Cacao Lab, the spin-off company from Ghent University of my colleague, Professor Koen de Wetting. So this was done basically with these cutouts, so to make sure that everything is close by and at hand. So you have to move as little as possible to do all the different activities and the different experiments. And here you see how first it was designed, and then it turned into practice. So you see here my colleague standing at the middle table with all the equipments around. Now Cacao Lab is expanding. We moved during Corona times, I think was from every difficulty you have to turn it into an opportunity. So during lockdown we had the opportunity to make use of the time and move to a larger location with multiple rooms and also pilot a hall. Here again, an example of the small distillery. So here you see the different zonings, also zonings related to customs and the duties. Taking in account all the permits, so from the Federal Agency of Food Safety, the environmental permit of the local town, and then all the permits, of course, of customs and duties. Let's talk about push versus pull. So you have repetitive manufacturing processes. And the push system was a very Western system, also dating back from the Industrial Revolution. So here the idea was we will work hard. If we are in bad numbers, we'll work a bit harder, and we just start producing, and then okay, we sell it. But of course, if nobody's buying, you end up with a huge amount of inventory, which is just sitting there, not moving out, not being sold. So you're blocking a lot of, you end up in serious cash flow issues. And about cash flow, we'll be discussing that in another module, which will be given by my colleague Xavier Hellink. The Asian system is actually more of a pull system. So there you have a emphasis on flexibility and simplicity, and also multi-use system. So it's not focusing on equipment which is very large, which can produce high amounts. It's more looking to equipment which is perhaps a bit smaller, but is flexible, so you can do more things with that. And also you're going to produce in such a way that you're satisfying your customer demand, but that you don't end up with huge amounts in your warehouse. And also now in the West, people are moving more towards this pull system. Another important aspect of operation management is forecasting. It's not guessing and predicting, but it's casting forward past data to see what products in what volumes need to be produced in the coming months or the following years. For that, you also have to take in account that for some products and services, you have a constant demand and a constant follow-up by production. You have linear increasing. So if you see here, you're increasing, you can cast forward past data and estimate that you have the demand will grow, and you have to adjust your production so you have increased amounts ready for your customers. And then you have seasonal products. Here you see an example of a seasonal product, and that's flip-flops. Nobody's selling nobody is needing flip-flops in wintertime. So, but in spring and summertime they're purchased. So your production needs to be accordingly. So there's no use to produce at the end of the summer huge amounts of flip-flops, because they will just be sitting there for the rest of the winter time. Another important part is capacity planning. We discussed that already a little bit. It's looking at what amount of products or services need to be produced, and also what need to be produced in the future. So you have to make sure that your capacity from both a machine and also labor is accordingly, and also looking towards the future. It involves looking at assessment of existing capacity, forecasting the estimates of future capacity needs, identification of alternative ways to modify this capacity. For instance, you can put another line there, or you can perhaps outsource it and have it toll manufactured if it's just a short moment in a peak, and ask additional capacity out there from other companies to cover a little bit this peak. And then financial technological evaluation of capacity alternatives. So it's looking at the current capacity, forecasting what the capacity will be in the coming years, looking at if there are alternatives, then changing production or equipment, or putting new lines there, and then perhaps better equipment at better prices. And then select the best suitable options. Now, before we go to procurement, we're halfway in the presentation. I would suggest, if you're fine, that we take a 5-minute break. We're 1 hour already moving ahead. So is it fine that we meet again in 5 to 10 minutes, and then we continue with the presentation? In the meantime, I'm not going to put the recording on hold, because if it stops, could lose all the rest. So let's meet again here at for you it will be 5:30 p.m. So in let's say in 6 minutes. Okay, hope you're all back. We had time for a little bio break. So procurement, what is procurement? That's identifying, when we talk, for instance, about capacity planning, all the required equipment for different activities, determine the specifications for those equipment, for instance, for pharma grade material or food grade material. The polishing needs to be stainless steel 316 with a polishing of less than 0.4 microns. Very important since it gives a huge competitive advantage, the price. So use my cursor again. So get minimum 3 quotations from 3 different suppliers and ask for references as well, and make sure that you're comparing apples with apples and pears to pears. So make sure you're also comparing specifications of the equipment. Evaluate these specifications, the prices, the cost also of maintenance, life expectancy, the quality of the equipment. Also, if the equipment has all requirements from a legislative perspective. For instance, in Europe, it needs to have these CE labels. And in the past, many goods came in, of equipment came in from China, and that also had a CE label, but it was different than the quality label for European, in European countries. So CE in China stood for China export. Of course, some of this equipment was not according to specs and safety guidelines, so basically they were not allowed in or were illegal to be used. Then you have, of course, very important price negotiations. You can buy or lease buy. And then to get some idea on prices of goods, you can have a look at Alibaba, where basically every type of equipment can be bought. Here's an example of how important it is for a good procurement and also resulting in a strong competitive advantage. This was a design and a compliance of a pot still. So here you see the drawing of the still, which was basically also my own design based on industrial archaeology and expired patents. So you have the pot still, the layer, the column with a pre-condenser or a deflagmator, and then the condenser, the parrot. So I asked around for around 150 liter to 200 liter pot still. And then, you had different providers or people that could produce these type of stills. But of course, everything need to be in compliance with, as I mentioned, these CE certificates and CE labels for the European Union. You could buy in Germany a Holstein with 120 liter capacity for about, and now it's already increased, 41,000 euros, not including VAT. Or a Kotte for 120 liter capacity, but then the working capacity is just 100 liters, keep in mind, for 36,000 euros, non-including VAT. But this was basically to German providers. I had another provider which could build my design, and I have now a capacity of, well, double the capacity, so working capacity 200 liters, multifunctional, for less than 1/3 of, well, let's say 1/3 of the price of this Holstein. So you can imagine that I have a much better competitive advantage compared to some of my competitors also producing spirits, but who had to purchase this much more expensive equipment. So before this is being paid back, they have to produce and sell much more spirits. Organizational planning. Very important, you see an organizational structure of an operations department where you have, for instance, a production manager with supervisors, a purchase manager to buy all the raw materials and packaging and what have you, and a logistics manager for the warehousing and also taking care of transport, and then a maintenance manager taking care of all the equipment, the building, and yeah, everything related to this whole operation. For organization planning, it's very important to have a job design. So make sure that the workers you need have the exact skills and background needed. Standard operating procedures. So this is a detailed description of a standardized task and process, and for this training is given to new employees, new workers, and which are also part of, for instance, the ISO system, so that you can show that you're working via very standardized, in a very standardized way. Product process charts. It's describing the processing of these industrial materials, and then designing it into numerous variety of flow diagrams. Here you see a computer software package that helps you with planning the organization. So you have the different work centers, the different lines for the different dates, and then different workers and goods are allocated and planned. So everything is ready and standing ready when you start production, and so that you produce also in such a way that you have sufficient goods in line with the demand of your customers. So sometimes you have very complex software packages, and this really helps, which is also required if you have a small operation. It's not an issue, but if you large operations with multiple lines, with multiple buildings, then of course it needs to be centrally very well organized, and then it requires these software packages to help out. For organizational planning, so looking at the workers, there are many aspects, so it's becoming a real HR endeavor. You can have look at job rotations, job designs. Also, you have external environment looking at legislation on safety, but also the unions. Then job description, the level of specialization, the specific expertise, electricians, chemical technical personnel, and how many hours people can work. If the demand is increasing, to see whether you're going to work in one shift or two shifts, is going to be planning also in the weekend, and this of course also has an impact on the salaries and on the well-being and holiday days of the different workers. Here you see safety regulations are becoming much more important. Here you see an example of some safety policies and safety regulations from the Heineken company, the Albert Maltings. My wife used to work there. Now she's managing the nuclear power plant near Antwerp. But this is an example of some safety regulations and policies. People were working in the past in a very hazardous way. So you see here, these things are not allowed. This is an example of working at height, but not in a proper way of doing this. So they have this very interesting construction built to change a light bulb, but this is absolutely not allowed. You have legal consequences also as an employer if your employees are doing these type of things and there's an accident. You're also personally responsible. Here you see a tourist walking by when there was a chemical spill to take a nice picture, but there should have been a good parameter set so that you don't have people walking by when you have these hazardous situations. Also working on electricity. Here's another guy changing a light bulb for a swimming pool on a ladder. This is what you can call a highway to heaven or hell, or these type of things, working on great heights. So these type of without any safety, people are working at great heights. This is not allowed anymore. So you have to have very strict regulations for your workers to make sure that that there's no accidents, that people come to work. There's no hazard, and they can leave back without being injured. Leave back home without being injured. As I mentioned, you have a whole series of legislation. Also in different countries there are different legislation in order to protect and also safety regulations for the workers in operations in the factories. And my apologies, that's in Dutch, but also you as an employee or as a manager are responsible by law for the safety of your people, of your workers. And that's why you have to have a very strong education of your workers and put a lot of emphasis on safety guidelines and make sure that all workers are in compliance with all these safety guidelines. Aggregate planning, we discussed capacity, we discussed already forecast. So if you have multiple production lines, for instance, in process systems with reactors, you also have to plan ahead which lines are going to be used to produce which type of product. So the amount of products you're going to build or be able to build, the different types, is also part of a business plan, but also part of your strategic plan. Needs to be discussed with sales and marketing so that everybody is well aware of what's going to be needed in the future of which type of products. As I mentioned, should be in a clear discussion and with the marketing and sales. And addresses demand side of its overall activities by showing the outputs it will produce of the different products on which specific lines. Here you see a template that I made, typical capacity planning or aggregate planning overview. So you have a line. So if you have different lines, this is for line A, B, or C, which type of product, and then the amount that needs to be produced for the coming months, and then the total of these products for a specific line gives you also the total capacity. So linked to the aggregate planning, you have also your capacity planning. This is the malting, Heineken's malting operation between Ghent and Brussels. You have different lines, and you see here, for instance, the aggregate planning for the different lines of which type of product that needs to be produced by when. Very important, inventory control. This is a technique of maintaining stock keeping at the desired levels. So it's good to have inventory, but not too much, because if your money is sitting in assets in the warehouse, and so you have this has an effect of your cash flow. It's impossible for each stock item to arrive exactly where and when it's needed. Sometimes the lead times for delivery times are fluctuating. So it's absolutely a disaster if you start production and you don't have your raw materials at hand. Same if you have a little bit of fluctuation in the demand of the customers. The inventory of the finished goods need to be such a way that it covers this Hello, everybody still there? I had a power failure. My apologies. So my battery went flat, and apparently it was not loading. Can everybody still hear me again?
Yes.
Okay, my apologies. I hope the recording is still continuing. Do you still see my screen, the shared screen?
No.
No? Okay, then I need to. Is it still recording? Okay, it's still recording, so that's fine. So I'll share my screen again. Now everything starts all at once. So I have a dog barking. My computer was flat. Anyway, so let's continue. It's back on the screen, the presentation, or not? Hello?
We can see.
Okay, thank you. Laser pointer. So inventory control, it's the techniques of maintaining stock at the desired level. We discussed these things. It's important for each stock item to be ready when it's needed at the production lines. Now, depending on how much you keep at stock, both of raw materials as finished goods, has a significant impact on your cash flow and on the costs. And you have several systems how to control your inventory. It can be a QR inventory system. Everything item is being marked and it's recorded when it's taken out of the warehouse, and when a certain minimum level is reached in the warehouse, then automatically you're ordering new materials. Or you can do it on a periodic system, so on a regular base, you look at the costs, you look at the inventory, the amount of goods still present, and then if you noticed that it's getting at a low level, then you start ordering again. Nevertheless, these things always happen as well during budgeting time of the year of companies, because during budgeting times you're going to have meetings discussing with marketing and sales and top management how much you're going to sell more the following year in comparison to what you have sold in the last year. So when you make the annual report, also you have to know at the end of the year how much is still in stock of finished goods and raw materials, because that's also part that needs to be handed over to government on your balance sheet and your profit and loss statement. Inventory control, important terms that you have perhaps already heard of, first in, first out, last in, first out, just in time, just ordering so that the products arrive just in time to be used. So you don't need basically warehousing or a large building to stow away all these raw materials. This is an example where of a corridor with you have an opening here. Here is no opening. So this is a very bad situation of warehousing. Here you can't do first in, first out. So if this was the first in, you can't put it back out. So here you end up with a terrible situation of first in, last out. Or you have to have a system here in place that which like type of a crane which can go and fetch these different items at these locations further down the hole. But that was also not the case. So this ended up in a terribly inventory mess. So you have different managing systems now also available. Nowadays, you also have large warehouses where there is no person running around anymore. So everything is computer organized. You have robots and forklifts that are automated. They know exactly by computer where which product is laying or standing on the shelves. And so yet at the entrance, you type in what you need, and then the machines go and get it and bring it to the location where it's required. So there is a lot of modern technology, artificial intelligence. So here you have also artificial intelligence to filling up your warehouse in the most efficient way at the lowest cost possible. And then you have other techniques like barcode scanners, RFID tags, and many more new features. For instance, for barcoding and these tags, you have it's a Belgium company, it's GS1, and there are very few people, but they're charging companies in order to allow them to use these barcodes. So with a few people with this great idea, they're earning huge amounts of money, and it's just allowing, you see it here, the trademark, this community trademark to be licensed to different customers, different companies, in order to allow them to use these barcodes. So there are important aspects of inventory control related to costs. So you have the cost of carrying the item itself, the cost of purchasing, procuring the item, the cost of actually having the item in the warehouse, and also there's of course a cost. What happens if you're out of stock and the raw material, the finished good, is not available? And then costs related to monitoring the warehouse and monitoring the inventory. And again, as with everything, you have now different models and different software systems that can help you out with these things. We discussed it earlier, there are modern recent aspects. It's also an area of academic study of operations management, like lean manufacturing. This came from Toyota. It's also related, it's an extension of this just-in-time system, also aims to reduce waste. This is a picture of one of the PhD students at Ghent from my colleague Xavier Helling on lean manufacturing, looking at best quality, lowest cost, shortest lead time, where you have the just-in-time and the Jidoka principle, and then have operational stability, where you have the most efficient way of operating with the lowest amount of energy required and the lowest amount of waste and lowest amount of reworks. So waste is also finished goods which are not according to specifications. Throughout the years, people find, we discussed also layout planning, and the most efficient way seems to be a U-shaped format. That makes good sense. So you have products in on one hand, you have the different activities, line or workstations, and then you have the products out. So most of the time, the layout is a U-shaped form. This is the House of Lean from the PhD student I mentioned, from my colleague Xavier Helling, where you have the different steps. So the base is the organizational structure, alignment, then the customer is a very important aspect in lean manufacturing, and then of course efficiency and basically cost should be at minimal. Remember also when I mentioned in the past your selling price was your cost plus your profit, but nowadays your profit is mainly the result of a similar selling price out there, but if you have a more cost efficient way, lower cost, you increase your profit. Six Sigma is linked also to lean manufacturing. because Six Sigma helps you to get in a very sustainable way more products in line with your specifications, so according to the quality expectations, and less waste. And then there is a whole management and it's also a business on its own, management system out there to help you with Six Sigma and other similar quality systems. And then there are trainings and people get certificates, and then it's like in martial arts where you have different green belts or black belts depending on which level you are in Six Sigma. And then the basic concept is getting very little standard deviations and as little as possible waste. So as products which are as close as possible to the standardized specifications related to quality. Here you have the mathematics of the Six Sigma. If you have a good understanding of what the concept is behind, it's fine. You don't need to know all the mathematics. I refer to that to my colleagues giving classes on mathematics. So if your Six Sigma increases, your costs go down, the errors go down, process time goes down, and you make more profit. Lean and Six Sigma, so speed and accuracy results, as I mentioned, in lower cost of goods produced, COGS, cost of goods sold. So you have lower cost of production, so you have a higher profit. Let's move a little bit to quality. So quality, as I mentioned already, is for or a product or a service. It's basically determined by your customer. You have quality policies, so that's a whole range of systems put in place in order to make sure that everything you do is is moving towards the quality desired by your customer. Quality planning, that's continuous improving your quality, getting more precise and accurate. Quality control is a lab activity that, for instance, for finished products and also incoming raw materials, analyzes them to make sure that they are according to specifications. And quality assurance is the whole system actually taking in account and working towards excellent quality and products being produced as much as possible without any waste to the preset specifications. It's an ongoing continuous system, but of course, if you are low quality, it's less and less, but you have to roll it all the way up. So it's not that difficult to get, for instance, of a chemical a purity of 70%, but if you want to have a purity of a chemical of 99.99%, it requires much more effort, and of course it's also related to price because it's getting much more costly. A chemical at 70% purity is costing much less than a chemical at 99.99% purity. So it's rolling up the ball uphill. It's continuing planning, doing, checking, acting, and of course requires, if you roll a ball uphill, it requires energy and time. And then you have to make sure as well, so as I mentioned, quality is that what your customers expect. If your customers expect for instance, a chemical of 70% purity, it's fine. You don't need to deliver them 99.99 because it also will be too costly. So set the requirements and quality guide specifications to what the customer wants and what you're selling. You have a statistical process control. That's a method of quality control using statistical methods. That's an ongoing system, and you can actually already forecast if things are going to get out of specs. It's also maintaining and controlling the process towards full potential. Products having as little as much products which are not to specs and which are waste or which have to be reworked in order to get them into specs. And you see, for instance, here the statistical data process control. So this is the center line. This is your average. And here you measure, for instance, let's say the pH of a product, and it should be this is the upper control limit, the lower control limit, and then you measure over time. So it's fluctuating, that's fine. But for instance, if it's going here already, it's not yet out of specs, but if it's continue like this, you can take already some actions before it's get to this point, and then check what's happening and why this is going up before actually it crosses this line of the limit of the upper control limit, and then your product is not according to specs anymore, and it's or waste or it has to be reworked, and both is a very expensive exercise. So this SPC system can help you already identifying upcoming problems, so you can take measures before actually losing money if it crosses the line and it turns into waste or rework. Quality systems, HACCP, so Hazard Analysis Critical Control Points. It's doing an analysis of your production process, for instance, also specifically for food, and see where things can go wrong and what the impact would be on your customers, on the consumers. But this is also part of a course of my colleague Lisbeth Jacksens. These HACCP systems are part of the ISO system. So it looks at during production here in the restaurant, where can things go wrong. So here the food fell on the floor. And also looking at the process where things can go wrong. This is actually a shop I visited in India. So this is the back where they produce a candy shop. This is the back where they were producing everything. Now, and in the front there was a nice shop. It didn't look too bad. But if you have to do a HACCP analysis on this thing here, it will be failing tremendously. There was also mold on the ceiling, so I thought this is a nice picture to be included on how not to do things. Traceability for food, and also the new technologies being developed with the blockchain. You have to more and more know exactly which ingredients are coming from where and which batches went into which final products. So it's throughout the chain very important to have traceability of all ingredients, of all finished products or all items used. Quality systems, good manufacturing practices, also part of ISO. It's very strictly regulated, for instance, for CGMP, that's quality systems for good manufacturing practice, specifically for the pharma industry. You see a series of characteristics here. So it's linked to the ISO. It also applies HACCP principles. It's also having systems in place for tracking and trace, and also if there is a problem, what are your policies for recall, so that you can inform all your customers and then have a recall program rolled out. It's also linked to your assurance of legal and supralegal product norms, but also it's linked to the assurances that you have to pay and put in place with the assurance companies. And the more stricter and the more harmful it can get, the higher, of course, your fees will be with the insurance company. And then if you have a whole set of monitoring and certificates related and auditing related to your permits. The ISO system, So the ISO system started in 1987. So it's documenting all your standard procedures that you're using in a company, not only in production. You can make it very complicated or you can keep it simple. So everything you put in your ISO system is documented and is audited. So you have ISO 9000, so that's quality management series. You have also ISO 14000, where also then environmental management systems are included. And then a specific category are ISO 17000, that's for laboratory accreditation. So that's very much linked to services and analysis. So it's monitoring training of staff, competencies of staff, calibration programs of the equipment that you're using, and so on and so forth. Now, as mentioned, if we would have been meeting face to face, then following this class, we would split up again in groups, and we would be looking again at our brewery that we want to establish in on the campus in South Korea. So you had to call your team. You get a building, the measurements of a building of 20 meters by 40 meters. And then the idea was to generate a proposal of an efficient layout for an operational site for a brewing unit of 500 liters, the warehousing, or 1,000 liters, warehousing, offices, visitor rooms. But you can do this now amongst yourself. Some other exercises I mentioned we will be doing together in class. I'll stop sharing my screen. Is okay. And are there questions that came up during the presentation or that you have? If nobody has questions, I'll stop recording.